Hi, so here I have a new research notebook, and we'll start by importing NumPy as MP. Also, bring in from stats models from import regression, and we'll also import statsmodels.api as SM, and we're going to go import matplotlib.pyplot as PLT. Okay, so the first thing we need to do is to get some data. And luckily, there's a nice thing called get price function. So we could start with, we could write start equals date 2016 1 and we're going to get end as 17. So all of that period for that year. And I'm going to choose some asset, and we're going to go ahead and choose Apple, get, and there's this function called get pricing, which allows us essentially to pass in some stock ticker and ask for some fields such as the price, and then we could put in the start date as start and the end date as we've defined it as end. So we run that, and that should get us the pricing for the asset, and we could just check out what the asset looks like. And this is essentially a time series which has a date and the actual price for Apple at that time. Okay, so we're also going to get some benchmark. So let's go ahead and say benchmark equal to get pricing, and we'll pass in SPY for the S&P 500, and essentially we're going to do the same thing, get the price, set the start date to start and the end date to end as defined previously. So that's going to get us the same information for the benchmark. And what I want to do is just compare the returns really quick. So let's say asset returns equal to asset, and we could get daily returns by simply saying percent change. And since we're going to be plotting this out, I'm going to grab everything beyond the first index point, and we're going to do the same thing with the benchmark. We'll say benchmark percent change 1, and we'll get everything and pass that through. Okay, so let's get that through and plot this out and say, so we'll say plot. What I'm going to do here is call assets returns dot plot, call that method first time, and I'm going to say bench returns and plot those out. And let's go ahead and call a legend here so we could see it plotted out against time. And here we are. Okay, so these are my daily returns from Apple as well as the S&P 500. And you can see they're not exactly lined up, but there are certain times where there's a dip in the S&P 500 and Apple dip as well. You could particularly see this around this July mark where essentially they have the same behavior. So there's definitely periods of time where Apple doesn't follow the market as all. So here's a green line, which is S&P 500, and these uh, blue peaks, which is for Apple. We can essentially call it the alpha, which is not behaving as the market. So we could use hedging to um, isolate the Apple shares. So we could say plot scatter, and we're going to scatter the benchmark returns versus the asset returns. And let's call it an alpha value of, let's say, 0.6. So you could have it a little bit see-through. And we could play around with this size. So let's say put down 50. It's not important, but it just looks nicer. And let's get the X label on the X-axis as SPY return on the X label. And for the Y-axis, it's asset return. In our case, it's Apple returns. So we run that, and let's see the scat plot looks like. So, okay, so you can definitely see there's some kind of relation between the SPY returns and Apple returns. So generally you can see as the market goes up, Apple goes up, and as the market goes down, Apple goes down. But there are some points here which are a little bit unrelated to that. So let's see how we could use hedging to isolate the alpha behavior. So in order to do that, we're going um, to do that by fitting essentially a regression line in there to get the alpha and beta values. So we're going to do it as the following. So let's say Apple is equal to the asset returns, and then I just want the values. And the difference between asset returns and asset different values, one has the time date indexes and one actually has the actual numbers. So essentially we need the numbers here. And we can say here SPY, and those are the branch returns, and we want the values there. So if we take a look at Apple, essentially it's just an array of numbers. And the other thing I'm going to do is say SPY constant, and I'm going to add a constant, and that way I could get the intercept. So I'll just show you how that looks like. So let's say sm.addConstant on SPY. So if you take a look at the initial SPY, it's another array of value of all these numbers here. And if I look at SPY constant, you'll notice that now it has this constant one along with that initial line. This allows us, this is going to allow us to get alpha on that, which is essentially the intercept. Okay, so now we have SPY constant. Now what we could do, we could say model is equal to regression dot linear model. We're going to ordinal least squares and pass an apple and pass in SPY constant here. And I could call fit over here to essentially fit the model on this data. And that should run really fast because it's a very small data set. It's quite simple. So you can say model.params, and that's going to return these two values here. And this is essentially y is equal to mx plus b. So what we could do here is say alpha beta equal to model.params. Then I could check out my alpha value, then I could check out my beta value. So here's my alpha value, here's my beta value for the relationship between Apple and the S&P 500 or the market. Now, this by itself doesn't really tell us very much, but let's actually plot this out. So we're going to have the same scatter plot from before. We're going to copy that and paste that in here, but we're going to add in a plot to represent that linear model that we created. So we're going to say, let's have the minimum S&P 500 is equal to benchmark values. Remember this is an NumPy array. And my maximum value is going to be equal benchmark returns values max. SPY value. So I'm just going to plot it from the minimum to the maximum SPY value. So through that. So once I have that, I have my minimum maximum. What I'm going to do to say is SPY line is equal to NP, a linear space array from the minimum SPY to the maximum SPY, and recipe 500, let's say 100 points. So that essentially gives me a bunch of X values from about here to here, and we're going to calculate what the actual line value is, the Y value, based on the alpha and beta. So we're going to say Y value equals to SPY line, all the X values, and multiply that by the beta, plus add in the alpha. So let's go ahead and run that. Wait, sorry, let me just set that, sorry. So I'm going to say plt.plot SPY line versus Y. Let's call it, let's give it color red. So now when we run that, you can see a regression line going through. So you can see this model, which is essentially tries the relation between the S&P 500, the market, and Apple returns. So now I'm going to show you how to implement a really basic hedge, which is essentially just using that beta value and turning it negative when essentially canceling out any relation between the market. So let me show you how to do that. So to implement a hedge, it's quite simple. So we could just say hedge equals to beta multiplied by the bench returns plus the asset returns. Except what we're going to do here, we're going to multiply this component by -1 just to reverse it. So there you go. And that should essentially act as if we were canceling out any effects from the market. And essentially we are shorting out the market position to a certain extent, to that beta extent, using the regression line. So I'm going to say hedge plot. I'm going to plot the as Apple with hedge. And then I'm going to take the other return here. So I'm going to take the asset return and plot that. And let's give this an alpha of 0.5 just to see it better. And then I'm going to also take the bench returns and plot that with alpha 5, so just to make it visible. Yeah, so, and then finally we're going to say plt.legend Just let me just make sure everything's all right here. Just have a smaller error. Apple with a hedge. Oops. Yeah, just put it on label. So here we go. Yeah. So now you can see this behavior. So just looking at the entire year's worth of information may not be particularly useful, but what I'm going to do is focus on a certain period of time when there's a big drop in the market, and that looks like that happens around July. It essentially drops right there. So you can see normal Apple stocks, if you had the position entirely in Apple, it also drop. But if you hedge it by using the beta factor over there, you see it's not affected that much. So let's go ahead and zoom in here. So we're going to do copy this, and I'm going to paste it here, and I'm going to set the X limit just to focus on that summer drop. So we're going to say PLT X limit, and then it looks like that happened around somewhere around July, June 2016. And let's have it go to August. Uh, and let's have a look. So plotting that out, now we see this behavior. So now what happens here? In July, the middle of June, there's a big market drop. So you can see the S&P 500, this red line, had a drop during that mid-June period. And Apple, since it was affected by the market, it was also dropped, but not as much as the market itself, but it did drop. You can see that quite clearly. However, the Apple with the hedge no longer follows that behavior. It just stays kind of flat. So you can see we've hedged against the market behavior. And if we take a look somewhere around this point, you can see that still it goes with the Apple equity in general. It wasn't affected by the market. So you can see around July uh, that they go out together. So it was only canceling out the portion that was affected by the market, but not the portion that's affected by the Apple stock. So you can see it's not affected so much by the market. So that also goes the other way around and around. So if there's a big market jump, Apple will not go so much. So you can see that we are sacrificing average returns for volatility. So we're going to actually show in much more detail the effects of hedging by calculating alpha and beta for the year 2016. And then we'll create a portfolio and show how the actual hedging affects return and standard deviation. So